Together with Cody King, I'm going to be describing some of the recent results from our investigation of physics students' mathematical difficulties. We used test items from which all the physics context has been stripped away, so they're just math problems. We're also working with Ohio State University to develop an online practice tool that we hope will improve performance. I'll discuss that later. We have given more than 5,000 diagnostic quizzes to students at Arizona State University on 2 different campuses, Tempe and Poly. We've also carried out 75 individual problem-solving interviews with students in these courses. And we have some comparison data I'll report on from the University of Colorado and Ohio State University. I want to show some of the problems on this diagnostic so that you know what I'm talking about here. These are some of the problems. Find the unknown angle in a right triangle. Find the unknown side in a right triangle. Find the area of a circle and of a triangle. Find the slope of a graph. Solve a pair of simultaneous equations with numerical coefficients and the same equations with symbolic coefficients. A multiple choice problem involving symbolic coefficients. And a variety of other analogous trigonometry and algebra problems. Here's a few of them. A primary sample population is composed of the algebra and calculus-based courses at Arizona State University, both the first and the second semester courses. So a total of 4 courses, but we do this on both the Tempe campus and the Polytechnic campus, so actually 8 sample populations. I'm going to go quickly through our findings and then come back to each one and discuss them in a little more detail. We find that error rates range from 20 to 70% on these pre-college mathematical operation questions, regardless of course. It varies from course to course, but that's the range. The results were highly consistent on the different campuses and the different universities, as I will show. When symbols, like letters, for instance, are substituted for numbers as the constant coefficients in algebra problems, student performance declines significantly. Even though the test items are very diverse, as you saw, the students' responses are highly correlated with each other and also with the total score in the test, to the point where you can actually use the class average score in a single test item to predict the class average total score in the test. There were consistent differences between the universities, which I will describe. We found during the problem-solving interviews that the students tended to self-correct many of their errors with little or no prompting. As many as 50% of their errors they would correct in that way. This led us to think that a lot of the errors could be described loosely as careless errors, and when we investigated more carefully, as Cody will describe, we found that when a larger proportion of the errors were careless, the students were actually scoring higher on the overall diagnostic, and I'll show those data. I want to show some of the correct response rates on just some illustrative samples from the test. And finding the unknown angle on the algebra-based course at Arizona State, 35 to 52% correct, depending on the campus. On finding the area of a circle, there was little difference between the courses, 57 to 76% correct as Arizona State. If you demanded that they supply correct units, the correct response rate went down significantly. 30 to 60% were able to give the correct slope of this graph. 55% of the calculus-based students at ASU Tempe solved this pair of equations correctly. I mentioned that the results were highly consistent. So, for example, this is a comparison of scores on each item at the Arizona State Polytechnic campus, the Arizona State Tempe campus, and the University of Colorado, this in the algebra-based course. You see that the results track each other pretty closely. Here, comparing just a smaller number of test items, comparing Arizona State Tempe, University of Colorado Boulder, and Ohio State University, very good agreement. And in the calculus-based course, comparing Arizona State Tempe and OSU, again, very good agreement on these items. As I said, when symbols are substituted for numbers as constant coefficients, performance declines. Here's the results on the calculus-based course at Arizona State Tempe. 79% were able to solve that pair of equations, and then when you switch those numbers out and simply put in letters instead of numbers, percent per correct response rate drops down to 55%, and that's very typical of many other problem pairs that we investigated. As I mentioned, the students' responses on these very diverse items were highly correlated with each other. I'll give some examples. This is the performance on items 3 and 18, and you see that most students either got both of them correct or both of them incorrect. Relatively few students got one correct and the other incorrect. Similarly, we can look at the students who got one item correct or incorrect and look at their total score on the test. So in green, those are the students who got item 6 correct. In red, the students who got item 6 incorrect. And we see the distribution of their correct response rates, where 1.0, of course, would be getting all 18 test items correct. You see there's a big difference in the average score, and that is typical for many of the test items, most of the test items. In fact, when you average the scores together and simply look at the class average scores, they're highly predictive to this point where you can look at simply the average score on item number 1, for example, that's on the horizontal axis, and use that to predict the total score on the full diagnostic, leaving out item 1. And you see it's highly predictive. And it's not just item 1. We find the same thing for item 18, that's this one here, and for many of the other items. You can literally predict the total score from one item on the class average scores. There were consistent differences among the campuses. So, for example, students at CU Boulder scored consistently 20% higher than those at ASU Tempe. And so here we're plotting the ratios of the scores on each test item. You see they all fall within a rather small band centered around 20% higher for CU Boulder. Similarly, when we compare the ASU Tempe and the ASU Poly students, 33% higher scores in ASU Tempe consistently. As I mentioned, the students tended to self-correct many of the errors they made during the problem-solving interviews. So what we did was we looked more carefully at the errors that could be described as careless. Now, Cody's going to describe that in more detail. I will just show some of the results here. So on the horizontal axis, what you see is the percentage of the errors on item number 14 that we classified as non-operational, or perhaps call them careless. Non-operational because the students showed on other problems that they knew how to do the basic operations. And the higher was the non-operational error rate, as you see, the higher was the overall score on the full diagnostic. Now, one of the strategies we're testing out is to give these online assignments the way that has been tested at Ohio State University by McCullough and Heckler, reported on by McCullough and Heckler and others in Andrew Heckler's group. And this is the basis of the current project we are collaborating on with OSU. The idea is to give the students a series of low-stakes homework assignments requiring multiple consecutive correct answers to get credit. And here's an example of a pretest question I gave at Arizona State on this is a physics quiz. Students had to find the net electrical force acting on the charge at the origin. We're looking for that type of answer there, something like that. Of course, I discussed this in class. We had a lot of group practice in class before the pretest was administered. After the pretest was administered, almost no review in class, but the students did have 3 separate rounds of these online practice homeworks called Essential Skills, where they get points awarded if they complete 4 in a row. And it's all or nothing. You either get no points or you get all the points for 4 in a row. And they went through that 3 separate times. Here's an example of one of those practice problems. The students are just given 2 vectors. They have to choose the sum of the 2. Here's another one. Students get many questions of that type. Again, they have to answer 4 in a row correctly. This is the post-test question I gave in the same course. And you see that the results indeed show that there was a significant improvement from pretest to post-test. So that gives us some hope that for certain types of errors, like these vector errors, which may be addressable through these assignments, whether the more deeply ingrained difficulties can be addressed in the same way is an open question. Thank you.